Welcome to Astronomy Daily, the podcast, your guide through the galaxy's latest wonders. Today's journey is packed with revelations that push the boundaries of our cosmic knowledge. We'll discuss the remarkable transition of NASA's Ingenuity Mars helicopter, reflecting on its unprecedented flights and its new purpose as a stationary observer on the red planet. Turning our gaze outward, we'll unravel the perplexing clues about the ice giants Uranus and Neptune. Their mysterious makeup poses questions that intrigue the astronomical community. Further afield, Titan's, Saturn's enigmatic moon, beckons us with the promise of secrets only NASA's Dragonfly rotorcraft could expose, as it receives a monumental green light to chart this alien terrain. Closer to home, we marvel at the Voyager team's remote engineering triumphs, delivering life-extending care to our farthest-flung explorers. On the cusp of a new era, Boeing's Starliner moves closer to regular human spaceflights with its trailblazing path to the International Space Station. And what would our understanding of the cosmos be without the army of citizen scientists? Their unparalleled contribution to NASA's cosmic census adds new depth to our grasp of the space that surrounds us. Prepare to be inspired as we journey through systems and stories that unite us under the same canopy of stars. Our celestial expedition begins right now on Astronomy Daily, the podcast.
The Astronomy Daily Podcast.
Ingenuity, the spunky helicopter that made history by taking flight on another world, has closed the chapter on its aerial adventures, but not without a significant legacy. Since its debut on the Martian dirt, Ingenuity proved to the world that powered, controlled flight was possible on Mars, surpassing all expectations. Initially, this technology demonstration was intended for a brief 5-flight lifespan, but remarkably, it has persisted for over 1,000 Martian days, cementing its place in the annals of space exploration. This little rotorcraft has now transitioned into a new phase, a stationary observer, silently perched on the Martian surface in the region known as Valinor Hills. Its mission? To carry on gathering data that might just revolutionize our approach to exploring the red planet. After a hard landing that halted its flight capabilities, the Ingenuity team devised a graceful retirement plan, one that would still allow the helicopter to serve science. Ingenuity's story is far from over. While it may no longer dance with the thin Martian air, its solar panels continue to drink in the sunlight, powering its systems to collect invaluable data. Each day as the Martian dawn breaks, Ingenuity rouses to life, conducting tests that scrutinize the performance of its solar arrays, batteries, and electronics. Truly, a machine that refuses to quit. And in a burst of defiance against the harsh Martian environment, it captures images with its color camera and documents temperature variations, giving scientists a long-term window into the dynamics of Mars's climate and dust activity. The bittersweet finale of active flight was marked by the flight team sharing final comms chocolate cake, while poring over data sent from nearly 190 million miles away, a testament to the incredible journey of a project that has broken boundaries and exceeded its creator's wildest dreams. And yet, the most poetic part of Ingenuity's story might be its final gift, a waiting trove of data that will remain nestled on the red planet, offering insights to future explorers, be they rovers, hovercraft, or even astronauts, whenever they come calling to Valinor Hills. In the outer reaches of our solar system dwell Uranus and Neptune, the distant ice giants shrouded in mystery. These celestial bodies, traditionally believed to be rich in frozen water, have revealed an unexpected twist in their composition, a twist involving methane, an element that might hold the key to unraveling the long-standing enigma of their formation. Recent studies have taken a closer look at these planets, which have only been graced once by a spacecraft, Voyager 2 in the 1980s. From the scant data available and extensive modeling, many scientists asserted that Uranus and Neptune were composed of a thin outer layer of hydrogen and helium, followed by a mantle of supersonic water and ammonia, with a rocky core resting at the center. The water element lent these giants their icy moniker, with estimates suggesting they could each carry up to 50,000 times the amount of water found in Earth's oceans. However, this watery perspective has been challenged. A group of researchers, led by planetary scientist Uri Malamud, decided to investigate the formation history of these planets more closely. They pondered over the compositions of the planetesimals, objects similar to comets from the Kuiper Belt beyond Neptune, that coalesced to form these giants. Their findings were startling. These planetesimals brimmed more with carbon than with water, suggesting the ice giants themselves might be more methane-rich than previously thought. To tackle this paradox, Malamud and his team meticulously crafted hundreds of thousands of models of the ice giants' interiors. Through this algorithm-driven approach, they sought to mirror the physical properties observed by Voyager 2 and telescopic measurements from Earth. They incorporated a suite of substances such as iron, water, and critically, methane. Their conclusions were striking. The models containing methane, fashioned into layers of solid or semi-solid under the immense pressure, echoed the mass and radius attributes of the actual ice giants. And here lies the crux of the methane mystery. The formation of methane ice could have been a product of the primordial hydrogen in the nascent planets reacting with the carbon from the accreted planetesimals. These reactions would have occurred under the intense conditions thought to have been present during their juvenile phases. With the revelation of this methane-enriched model, our understanding of the creation of Uranus and Neptune is poised to take a riveting turn. The implications of this discovery are significant. They demand that we reconceptualize our theories on celestial formation and the metamorphosis of matter in the cosmos. These findings might also inspire more focused missions to these distant worlds, where we can probe their depths in greater detail. Until then, the methane mystery continues to loom, an enigmatic chapter in the saga of Uranus and Neptune, the ice giants that might have danced with methane in their formative years. In an exhilarating leap forward for space exploration, NASA has officially given the green light to the audacious Dragonfly mission, setting its sights on Saturn's enigmatic moon, Titan. This is no ordinary mission. In a feat of technological prowess, NASA will dispatch a rotorcraft, akin to a drone on Earth but incomparably more complex, designed to traverse the alien landscapes of this distant world, a moon that captures our imagination with its thick atmosphere and organic-rich surface. The Dragonfly rotorcraft has successfully passed the crucible of its preliminary design review, surmounting challenge after challenge to ensure every aspect of the design is up to the task. Yet, it faced an obstacle more familiar here on Earth, adapting to budgetary constraints. With perseverance akin to the mission's innovative spirit, an updated and approved budget now allocates a total lifecycle cost of $3.35 billion, a testament to the mission's valued potential and the dedication behind it. We are looking at a launch date set for July 2028, a graceful nod to the careful and thorough preparation behind such an ambitious endeavor. While this reflects a delay from the initial proposal, improvements have been made to ensure a timely arrival at Titan by opting for a heavy-lift launch vehicle, shortening the mission's cruise phase and, in turn, enhancing our anticipation. Upon touchdown in 2034, Dragonfly will initiate a series of flights across Titan's varied terrain. Picture this: a rotorcraft, whirling through the dense nitrogenous air of another celestial body, exploring dozens of locations thought to harbor the building blocks of life. This will be the first time NASA flies a vehicle for science on another planetary body, a marquee event in interplanetary aviation. Led by the Johns Hopkins Applied Physics Laboratory and a coalition of partners both stateside and internationally, Dragonfly's mission is nothing short of historic. As it progresses to the final design, followed by the meticulous construction and testing of the spacecraft and its instruments, we can only envision the groundbreaking science that awaits. Imagine the data streaming back to Earth, possibly revealing how prebiotic chemistry weaves itself into complex organic molecules, potentially akin to those present on our home planet before the dawn of life. Dragonfly doesn't just aim to expand our knowledge of the cosmos. It seeks to unravel the very secrets of life's universal recipe. Indeed, Titan beckons with its liquid methane lakes and dense, hazy atmosphere, promising a story of cosmic proportions. With Dragonfly, we are on the cusp of turning the pages of this alien moon story, probing the solar system's most profound mysteries, and perhaps finding echoes of Earth's primordial past, or the inklings of life's cosmic potential. This mission is more than exploration. It's an odyssey, set to cut through the heavens, to the shores of an ancient and icy moon, where history awaits the beating wings of Dragonfly. In a remarkable display of ingenuity not seen since the spacecraft's launch in the late 1970s, the Voyager team has achieved what could be considered a pinnacle moment in remote space systems engineering. Voyager 1, the most distant object ever crafted by human hands, now drifts more than 7 billion miles from Earth. That's over twice the distance to Pluto. This intrepid explorer has been silently gliding through the vast emptiness on its journey towards interstellar space, relaying precious scientific data back to us, but recent challenges have demanded unprecedented actions. Engineers back at NASA's Jet Propulsion Laboratory confronted an obstacle that could typically warrant close-up, hands-on attention. In the case of the Hubble Space Telescope, astronauts conducted in-orbit maintenance. However, such a possibility is a far-fetched dream when your patient is coasting through the cosmos, far beyond Hubble's reach. So they did the next best thing. They sent commands across the interstellar expanse, breathing new life into the spacecraft's backup systems that had laid dormant for the better part of 4 decades. The Voyager 1 team carefully awakened a backup attitude control system. This intricate procedure included the activation of alternative sun sensors and star trackers, components designed to maintain the spacecraft's orientation. To appreciate the scale of the challenge, consider that it's a task executed with a time lag of nearly 12 hours for signals to travel each way at the speed of light. Picture that, 12 hours waiting for a nod, a confirmation, from a robotic emissary so remote that its signals are just whispers from the cosmic void. Flipping the switch on equipment that had been metaphorically gathering dust since Voyager 1's scenic pass by Saturn in 1980 was no small feat. Initial diagnostics indicated a troublesome analog-to-digital converter might fail, jeopardizing the spacecraft's communication with Earth. They meticulously planned the switch, initially testing a temporary changeover with a built-in reversal back to the old system, just enough buffer to ensure the backup components would perform flawlessly. The detailed preparation was successful, though not without a hiccup. Voyager 1 unexpectedly fixated on the sun during the temporary switchover, an unforeseen lock, but an obstacle soon overcome with the spacecraft instructed to maintain steadiness using its gyroscopes. Voyager 1's original designers, their foresight bordering on the prophetic, equipped the spacecraft with redundant systems, perhaps aware that they were crafting an artifact of human achievement that would far outlive its expected lifespan. Indeed, the perspicacity to include backups has been a paradigm of Voyager's mission, a legacy continued by the remarkably small team of 14 overseeing the spacecraft today, down from the original 300+ in the era of its grand tour of the outer planets. The successful handover to Voyager's backup systems has provided more than just extended life to the spacecraft. It's offered renewed faith in human ingenuity that bridges the vast distances of space. As it continues on its path, Voyager is a testament to our enduring desire to explore, to learn, and to push the boundaries of possibility. It's the will to strive, to seek, to find, and not to yield that propels humanity's voyagers of the cosmos deep into the unknown.
The Astronomy Daily Podcast.
In the realm of human spaceflight, a significant milestone is upon us with Boeing's Starliner spacecraft gearing up for a momentous voyage. This critical expedition to the International Space Station, or ISS, is not just a routine trip. It is a vivid demonstration of the strides we are making toward the next chapter of regular human spaceflight operations. As the sun peered over the horizon this April 16th, the Starliner made its cautious journey on a trailer towards the United Launch Alliance's Atlas V rocket. This pre-dawn rollout, while seeming straightforward, signifies a leap forward. Aboard this mission, called the Crew Flight Test, are 2 veteran NASA astronauts who have both honed their skills as Navy test pilots: the mission's commander, Barry Butch Wilmore, and pilot Suni Williams. Their expertise will be pivotal in this critical phase of testing. The 6-mile road trip from NASA's Kennedy Space Center all the way to the vertical integration facility where the union with the Atlas V will take place is an emblem of progress and anticipation. This pairing of rocket and spacecraft isn't just about integration. It's a harmonization of years of human endeavor and engineering prowess, culminating in a platform that will carry humans back to the vanguard of space exploration. During the upcoming CFT mission, slated for early May, the Starliner will undertake a week-long journey to dock with the ISS. The essence of this mission lies in vigorously testing all major onboard systems with astronauts at the helm, an acid test following Starliner's 2 uncrewed flights. The first, back in 2019, fell short of reaching the ISS, and a second attempt in 2022 successfully made the rendezvous, validating substantial modifications to the spacecraft. The audience of this rollout wasn't just engineers and mission planners. Astronauts designated for future expeditions aboard the Starliner were also present. Among the onlookers for the maiden crewed mission were the crew of the first operational 6-month ISS mission, Starliner 1, scheduled for 2025, including NASA's own Scott Tingle, Mike Finke, and the Canadian Space Agency's Joshua Kutrick, amplifying an air of camaraderie and collective purpose. Despite past challenges, the joint assurance from Boeing and NASA, echoed by the astronauts, aligns on one certainty. The Starliner has emerged ready and able to safely carry crews. This upcoming crew flight test will serve as a robust verification of Starliner's readiness for long-duration missions to the ISS. This narrative isn't just about the intersection of technology and human ambition. It is also a testament to a significant partnership. Since 2014, Boeing and SpaceX have been in a groundbreaking collaboration with NASA for commercial crew missions to the ISS. Boeing's contribution, the Starliner, valued at $4.2 billion, is standing on the threshold of joining SpaceX's Crew Dragon in the canon of spacecraft, supporting the ballet of orbital rendezvous and the continuity of research and life aboard the ISS. Thus, as the Starliner prepares for integration with its Atlas V rocket, and ultimately the journey to the stars, we stand at the cusp of ensuring a seamless transition of space station crews. It is a strategic approach that promises to reshape human spaceflight for the generations yearning to reach above and beyond. In today's episode, we're shedding light on an extraordinary collaboration that's expanding our understanding of the cosmos, right from our backyard. I'm talking about none other than the Backyard World's Planet 9 Citizen Science Project, a venture that exemplifies the power of collective astronomical inquiry. Citizen scientists, armed with their curiosity and dedication, have teamed up with professional astronomers to embark on a celestial census. This isn't your typical neighborhood count. It's a comprehensive survey of cosmic objects within 65 light-years of the sun. Think of it as taking stock of our own cosmic vicinity. The results are nothing short of astounding. The census reveals a space teeming with diversity, from stars fueling their own fiery furnaces to brown dwarfs, the enigmatic in-betweeners of the stellar family. Initial counts suggest there are about 4 times as many stars as there are brown dwarfs in this swath of space, and this could have fascinating implications for our grasp of star formation. The insights gleaned are hinting at a universe where low-mass objects are the norm rather than the exception. What I find most enthralling is the role of brown dwarfs in this cosmic tapestry. Brown dwarfs walk the line between stars and planets, too hefty to be the latter but lacking the intense nuclear fires that define the former. Peering into the data, scientists are starting to piece together another clue into the star formation puzzle. It's possible that different initial conditions, or seeds, could be determining the fates of these celestial bodies, resulting in either a star or a brown dwarf. The efforts of these amateur astronomers, from the schoolteacher to the retiree, have effectively catapulted the research timeline, accelerating discoveries that might have otherwise taken a decade or more. It's particularly impressive considering they have sped up the identification of these objects by sifting through animations of images captured by NASA's WISE mission, diligently spotting the subtle movement of celestial entities against the starry backdrop. And the human dimension of this project is as inspiring as its scientific yield. Take Leopold Grames from Paris, whose day job involves overseeing the security at one of the world's busiest airports, but whose passion for the stars led him to co-discover new brown dwarfs and even develop software to aid in the search. His story is a testament to the boundless potential of citizen science. This census not only charts our cosmic neighbors, but also beckons us to ponder the origins and processes that crafted our stellar suburb. The Backyard Worlds Project is a remarkable example of what we can achieve when we bring together the professional precision of scientists and the boundless enthusiasm of citizen explorers. For those of us captivated by the universe, it's a heartening reminder that the quest for knowledge is a shared endeavor, one that transcends professional boundaries and unites us under the canopy of stars we all call home. Thank you for joining us on this journey through the cosmos on Astronomy Daily, the podcast. It has been an illuminating tour of the latest astral news and insights that expand our understanding of the universe we inhabit. From marveling at the Ingenuity Mars helicopter's new chapter on the Red Planet to unraveling the mysteries of the icy giants Uranus and Neptune, we've explored the depths of space and the intricacies of celestial bodies. Dragonfly's upcoming voyage to Titan and the impeccable engineering triumphs sustaining Voyager's interstellar quest remind us of our boundless curiosity and the technological marvels that allow us to reach into the unknown. Boeing's Starliner's imminent mission signifies a new era in space exploration, one where the frequency and scope of human spaceflight are poised to accelerate. And we cannot overlook the exceptional contributions of the citizen scientists working alongside professionals to sketch a detailed cosmic census just a stone's throw away from our sun. As we wrap up today's episode, I invite you to continue the adventure with us by visiting our website at astronomydaily.io. Here, you can delve deeper into extensive space news, catch up on previous episodes, and become a part of our growing community by subscribing to our free daily newsletter. Remember, wherever you may find yourself, the wonders of the universe are never out of reach. Astronomy Daily, the podcast, is available wherever you enjoy your podcasts: Apple Podcasts, Spotify, iHeartRadio, or directly from our website. So, whether you're a dedicated stargazer or a casual observer of the night sky, know that you are always just a stream away from the latest revelations in the stars above. Until next time, keep looking up and let your curiosity lead the way. This is Anna, saying goodbye for now, and clear skies to all our listeners.
The Astronomy Daily Podcast.